In this video, I will share how I passed the Google Cloud Professional Data Engineer Certification exam in 14 days after falling on the first attempt. I collected immediately my learning path, study materials, and test experience, especially the lesson learned and further learning notes for the second attempt of the exam. I usually got my IT certification in the first attempt, but this time I did twice. The big challenge is that you need to choose the best solution from all durable answers in some questions. So this certification exam is very difficult. At the time of recording this video, the Google Cloud Professional Data Engineer Certification exam is a 2-hour exam with 40 questions. All questions are multi-choice and multi-select. The questions in the exam focused on the real scenario-based use cases and your hands-on experience with Google Cloud Service. You can take it remotely. There are no prerequisites for this exam, but Google expects you to have hands-on designing and operating data process systems, use the Google Cloud Service, and the big data analytics experience. Take some time to go through this page on the exam guide. You can find many good structured online courses for this exam. Take the free trial opportunity of those courses to find the one that fits with your learning style. At the time of recording of this video, Google Cloud provides free training courses for its certification exams. After you click Register Now, you will go to the certification journey page. Select the certification you will take in the registration form. Then you will receive an email with a Pluralsight and QuickLabs offers to help you prepare for your certification exam. It's a 6-week preparation for the exam with a 1 month free access. If this offer is no longer available when you are viewing this video, you can go to the Coursera or Pluralsight directly to search for this course. I took data engineering with a Google Cloud Professional Certification training path from Coursera. There are 6 courses in this professional certification training path. This course provides you comprehensive information on Google Cloud Data Engineering fundamentals, hands-on laboratories in the QuickLabs, and sample exam questions. Take the benefit of the free enrollment option. Save the PDFs of the slides from these courses to review them before the exam. The certification exam will expect you to not only understand big data and machine learning fundamentals, but also be able to design, build, operationalize, secure, and monitor data processing systems. So you should gain hands-on experience with Google Cloud free tier. Coursera and Pluralsight courses provide hands-on laboratories. I did all the hands-on practice in the QuickLabs. You will face the exam questions very similar to the hands-on practice from QuickLabs. I also collected the GCP Professional Cloud Architect Certification learning videos and the Google Cloud Professional Data Engineering Certification learning videos from Google Cloud for your reference. Both videos will help you to learn the fundamentals of Google Cloud Services and the best practice of each core service in the exam. I will make a series of last-minute cheat sheets like I did for the GCP Professional Cloud Architect certification, especially the GCP documentation, learning materials, and trick topics that I use for the second attempt. Now let me share my lessons learned from my online exam experience. You will receive either pass or fail at the end of the exam. There is no official passing score from Google. It will take 7 to 10 days for Google to evaluate your remote test result before Google releases your certification information. If you failed on the first attempt, then you need to wait 14 days to re-register for your next attempt and pay for each attempt. You can register the exam on the same day when you feel you are ready. You should have enough time to read and understand each question, so don't rush in to complete the exam. It does have long description questions that are a little bit longer than you saw on Google sample questions. I did have 2 very similar sample questions in the first attempt and 1 sample question in the second attempt. So use Google sample questions as much as you can and try to understand the key points behind all of those questions. If you are stumped on something, don't spend too much time on it. Just flag those questions for later review and select your best guess. If you failed on the first attempt like me, instead of spending time to blame yourself, just write down all the topics, questions that you suspect you might be wrong. In my case, I wrote down the window functions in the data flow, difference between Kafka and PubSub, BigQuery table access, etc. for the further learning. The example will test your deep knowledge and your hands-on experience in big data analytics and machine learning. So even you have basic knowledge of GCP services, or you passed the GCP Professional Cloud Architect certification like me, you still need to spend a lot of time to deep diving into those topics. I will share the detailed documentations that I used to learn for my second attempt in the series videos of last-minute cheat sheets. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. Thank you. Today, let's go through the cheat sheet of Google Cloud Services for Big Data Analytics. I used this data lifecycle solution as my last-minute cheat sheet for both the GCP PCA and the PDE exams. I strongly recommend you to read the whole article. I will point out the key points for both certification exams, and I will make the follow-up last-minute cheat sheet series of the service that lead to deep dive for the exams. The Google Cloud provides a 4-step data lifecycle. Both the certification exams will test your understanding on these 4 steps and choose the right cloud service in the different user scenarios. Let's open the Google Cloud products list in another browser. I'll circle the service that appear in my certification exams for your reference. In the ingesting app data, one of the important app data is log data from apps running on Google Cloud. At the time of recording this video, Google certification exam still using Stackdrive. Stackdrive has monitoring, logging, trace, error reporting, and debug. I highlight the key points to remember for the exams: monitoring, which has the alert included, logging for the real-time logs, error reporting for the application errors, debug for debugging code in production, tracer for find performance bottleneck. You will also have the questions on how to use the logging or monitoring agents in the PDE exam. In this section, PubSub for real-time messaging, Well, GCP PCA exam focuses on the data flow architecture. For example, ingesting data from PubSub, transforming data on Dataflow, then loading the data on BigQuery for analytics. I highlight here that PubSub and Dataflow, they can work together to strict message ordering. But in the PDE exam, we'll test your ability to design the data pipeline and the processing solution. So I will make another cheat sheet on the PubSub for PDE exam. Move to the next one. How to ingest bulk data and compare the difference of 4 ways to transport data. In general, if you see question about transforming 10 terabytes data from on-prem to Google Cloud, the fast way is to use a transfer appliance. If you make a backup from another GCP bucket or AWS S3, then use a storage transfer service. BigQuery data transfer service is used to transfer data from another Google SaaS, for example, Google Ads, YouTube, to BigQuery for analytics. gsutil command is usually used to transfer of large numbers of files by using the multi-threading option for less than a few terabytes of data. Now at step 2, store data. For details of storage and database decision, please review the video GCP PCA last-minute cheat sheet on storage and database decision tree. You will have questions on choosing the right storage class from Google Storage. So please spend some time to understand each store class's availability and its cost. There are 2 choices for relational database, Cloud SQL and Spanner from Google Cloud. Highlight the key points for PCA exam. Cloud SQL supports workloads up to 30 terabytes for both MySQL and PostgreSQL. You can install the database in the Google Computer Engine if the version number isn't supported by Cloud SQL. I did have this kind of question in my PCA exam. The key point for the Spanner is that Spanner can horizontally scale out. Now move to NoSQL databases. Key points for Bigtable: consistent, no latency, and high throughput for terabyte to petabyte scale workloads. For the PCA exam, you only need to understand Bigtable's use cases. For PDE exam, you need to understand the schema design, such as 12-verse wide schemas and the best practice on the Bigtable. The other NoSQL choice from Google Managed Service is FileStore. FileStore has a native and a data store modes. At the time of recording this video, Google certification exams still using data store in the exam. I'll make a cheat sheet on the 2 modes and the difference between Bigtable and data store. At step 3, data process and analyze, Google provides the comparison among Cloud Data Prog, Cloud Data Flow, and the Cloud Data Prep. The information listed in the article is not enough to pass the PDE exam, so I will make the cheat sheet on these 3 services. The same thing on BigQuery. We do need to dive deep on the BigQuery to pass the PDE exam, so stay tuned for the BigQuery cheat sheet. Understanding data with machine learning, provides a good instruction on each machine learning API for GCP PCA exam, but it is not good enough for the PDE exam. Again, please stay tuned for the video of machine learning cheat sheet. The last step is to explore and visualize data. You only need to understand the basic knowledge on Data Lab, Looker, and the Data Studio. To incorporate all of the above steps and operate the data workflow, you will use the orchestration service. Any question you see in the CERT exams on the data workflow orchestration, the correct answer will be Data Composer. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. Thank you. In my blog Last Minute Cheat Sheet for GCP PCA exam, I list 4 decision trees to help you to choose the right services in the exam. Let's walk through the first one, storage and database decision tree. The decision tree starts with the questions: is your data structured? If it is not, choose cloud storage. If your data is structured, does your workload focus on analytics? If it does, you will want to choose Cloud Bigtable or BigQuery, depending on your latency and update needs. Otherwise, check whether your data is relational. If it is not relational, choose Cloud Firestore. If it is relational, you will want to choose Cloud SQL or Cloud Spanner, depending on horizontal scalability. You can go to the following 2 GCP web pages to review GCP storage products and GCP databases options. Let's quickly go through them. The first one is the storage products. You can see the use cases for each product. For example, cloud storage for object, blob storage, archive storage, the persistent disk and local SSD for block storage. By the way, my blog lists the comparison among the storage options, and I will make a video to talk more details among persistent disk, HDD, and SSD. You can see the file store for file storage. Mobile apps use cloud storage for Firebase. And you will see the transfer service to transfer data from on-prem to cloud or cloud-to-cloud transfer. By the way, I didn't see any collaboration questions in my exam, but you might want to know the high-level concept of the collaboration products just in case. The second page is on the databases options. The GCP database servers for the relational and non-relational databases such as Cloud SQL, Cloud Spanner for relational databases, Cloud Bigtable, Cloud Firestore for NoSQL databases. I like this comparison table on what are you building. For example, if you need global data distribution, and scale insurance for the relational databases, then you should choose Cloud Spanner. It also lists the other features on those services, such as replica consistency, the multi-primary joins and complex queries, real-time sync. So this is to give you an idea how to choose the right service for your database options. You can also go to the GCP documentations to review the details on each GCP service. At the last, I summarized GCP storage and database decision tree with the keywords and the use cases for you to easily remember for the exam. The options divide into object, relational, non-relational, and data warehouse. For example, the cloud storage is for unstructured data, archive, temporary storage. It is the lowest cost storage option for up to X bytes. The use cases include images, media serving, data lakes, or backups. A Cloud BigQuery data warehouse service is different than the other OLTP service in this table. It is for OLAP. Well, you got the points. Pause this video if you need more time to review the keywords of each service. Thank you for your time and see you in the next lecture. In today's last-minute cheat sheet for PDE exam, let's compare two fully managed relational database solutions from Google Cloud, Cloud SQL and Cloud Spanner. Cloud SQL is a fully managed relational database service for MySQL, PostgreSQL, and SQL Server. It supports performance-intensive workloads with up to 60,000 IOPS, easily scale up as your data grows, and up to 64 processor cores, and more than 400 GB of RAMs, up to 30 TB of storage, and the read replicas to handle increasing read traffic. You can review the main features of Cloud SQL and which database engines support these features in this page. Also, go to the Cloud SQL features page, which describes the major features and the capabilities for which versions of DB engines. You should understand the difference between failover and read replicas in Cloud SQL before the exam. Here is the architecture diagram on failover. Failover is for Cloud SQL high availability. The primary instance and the standby instance are located in two zones within the same region, again within one region. Review this page for more details on HA. Well, replication is the ability to create copies of the Cloud SQL instance or from on-premise database and offload work to the copies. Cloud SQL supports three types of read replicas. Review the replica use cases and a quick reference before the exam. These two architecture diagrams show how to securely connect to a SQL instance. The Cloud SQL proxy provides secure access to your instance without the need for authorized networks or for configuring SSL. You can use a service account to authorize access from Google Computer Engine, Google App Engine, Cloud Functions, and Cloud Run. Another option to access a Cloud SQL instance by using private IP. You're using private service access. Private services access is implemented as a VPC peering connection between your VPC network and the underlying Google Services VPC network where your Cloud SQL instance resides. If you need manually control over the SSL connection, you can generate and periodically rotate the certificates yourself. Otherwise, you can use an unencrypted connection by authorizing a special IP address to connect to your SQL server over its external IP address. Cloud SQL uses Google Managed Data Encryption Keys (DEK) and Key Encryption Keys (KEK) to encrypt Cloud SQL, but you can also provide a custom Managed Encryption Key (CMEK) to do data at rest encryption. I didn't have any questions on Cloud SQL IAM in my exam. The Cloud SQL IAM is on project and Cloud SQL instance level. Provide 2 access control links for your reference. In Cloud SQL best practices, pay attention to the following best practices for read-heavy workloads and read replicas to offload traffic from the primary instance. Shard your instances where possible. Speed up imports by using the appropriate MySQL dump command when you export. Review the details of the best practice if you have time. In our next 2 videos, I will go through the cheat sheet of Cloud Spanner and the Relational Database Service decision tree. This is the second part of the last-minute cheat sheet on Cloud SQL versus Spanner. We reviewed the last-minute cheat sheet of Google Cloud SQL last time. Now, let's go through the cheat sheet of Cloud Spanner. Cloud Spanner is a fully managed relational database, built for horizontal scale to petabytes. It supports high availability with a multi-region instance and provides transparent, synchronous replication across region and multi-region configurations. Purpose-built for external, strong global transactional consistency. Let's take a look at this automatic synchronous replication for high availability. Cloud Spanner has 3 types of replicas: read-write replicas, read-only replicas, and witness replicas. Read-write replicas support both reads and writes. Read-only replicas only support reads, not writes. Witness replicas don't support reads but do participate in vote to commit writes. Single region instance use only read-write replicas, while multiple region instance configurations use a combination of all 3 types. Review this page on the details of replicas. Google Cloud IAM allows you to control user and group access to Cloud Spanner resources at the project, Cloud Spanner instance, and Cloud Spanner database levels. I didn't have any question on Cloud Spanner's IAM in my exam. Provided the access control link for your reference. Keep in mind, Cloud Spanner is not a drop-in replacement for MySQL, and it is not MySQL PostgreSQL compatible. it does require some work to migrate. However, when making a transition, you don't need to choose between consistency and scalability. Please review this page on the details of migrating from MySQL to Spanner. Also, I provide this page for your reference on some of the other Google Cloud products that are integrated with Cloud Spanner. I found that Cloud Spanner best practices, especially bulk loading best practices and schema design best practices, help me a lot to answer some questions in the exam. In bulk loading best practices, pay attention to import a database use Avro files, and click the link of the best practices for importing Avro files to learn the details. In schema design best practices, pay attention to how to choose a primary key to prevent hotspots, such as avoid monotonically increased primary key, hash the unique key and spread the writes across logical shards, and use a universal unique identifier. Review the highlight sections before the exam. Now we finished the last-minute cheat sheet of Cloud SQL and Cloud Spanner, two fully managed relational database services in Google Cloud. Next video, I will go through the relational database services decision tree and how to use the decision tree to answer the relational database questions from the PDE sample questions. This is the final part of the last-minute cheat sheet on Cloud SQL vs Spanner. In this section, I will go through the relational database service decision tree. You can pause this video to review the last-minute cheat sheet of Cloud SQL and Spanner videos before this one. I also made the video on Google Cloud Storage and Database Decision Tree in GCP PCA's last-minute cheat sheet. You can also review that one before this one. There are three options for using relational database services in Google Cloud: using Cloud SQL, Cloud Spanner, or hosting the database on a VM using the GCE. If your relational database requires special operating system, custom database configuration, or special backup requirements, then you should host the database on a VM using GCE. Use cases fit Spanner based are sharded RDMS, scalable relational data, require manageability, or HA, multi-region support, or strong consistency. Otherwise, use Cloud SQL to support workloads less than 30 terabytes relational database. Now let's use the last-minute cheat sheet on Cloud SQL vs Spanner to take a look at the two sample Google PDE questions. You are designing storage for two relational tables that are part of a 10 terabytes database on Google Cloud. You want to support transactions that scale horizontally. You also want to optimize data for range queries on long key columns. What should you do? A. Use Cloud SQL for storage and second indexes to support query patterns. B. Use Cloud SQL for storage. Use Dataflow to transfer data to support query patterns. C. Use Cloud Spanner for storage and secondary indexes to support query patterns. D. Use Cloud Spanner for storage. Use Dataflow to transfer data to support query patterns. Now pause the video and try to answer it yourself. Ready? I highlight the keywords of this question. If just a 10 terabytes database, then Cloud SQL should be okay. But it requires a scale horizontally, then it should use Cloud Spanner. Adding a secondary index on the long key column makes it more efficient to look up data in that column. So the answer is C. Now let's take a look at another one. You are designing a relational data repository on Google Cloud to grow as needed. The data will be transactionally consistent and ended from any location in the world. You want to monitor and adjust the node count for input traffic, which can spike unpredictably. What should you do? A. Use Cloud Spanner for storage. Monitor storage usage and increase node count if more than 70% utilized. B. Use Cloud Spanner for storage. Monitor CPU utilization and increase node count if more than 70% utilized for your time span. C. Use Cloud Bigtable for storage. Monitor data stored and increase node count if more than 70% utilized. D. Use Cloud Bigtable for storage. Monitor CPU utilization and increase node count if more than 70% utilized for your time span. Now pause the video and try to answer it yourself. Ready? I highlight the keywords of this question. Relational data, transactional consistent, any location in the world, then you should use Cloud Spanner. Bigtable is for the NoSQL database that I will cover in the next video. Spanner will use the available CPU resource to handle the input traffic spike, so you should monitor the CPU utilization. The correct answer is B. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. Thank you. In today's last-minute cheat sheet session, let's compare two fully managed NoSQL database solutions from Google Cloud, Cloud Bigtable and Cloud Firestore. This is the first part of the last-minute cheat sheet of a NoSQL database, Cloud Bigtable. Bigtable is a fully managed petabyte scalable NoSQL database service for large analytic and operational workloads. Cloud Bigtable is ideal for storing very large amounts of single-keyed data. It supports high read and write throughput at a very low latency. And it is an ideal data source for MapReduce operations, such as HBase replacement. This video will focus on last-minute cheat sheet, so I won't spend time to explain Bigtable's architecture, such as instances, clusters, nodes, and storage model. If you are new to Bigtable, please pause this video and review the big data architecture first. Now let's take a look at the Bigtable's schema design. The general concepts for designing the schema are: each table has only one index called the row key. All operations are atomic at the row level. Ideally, both reads and writes should be distributed evenly. It's better to have a few large tables than many small tables, etc. There are three types of row keys: reversed domain names, string identifiers, and timestamps. You can use one or using one as part of the row key, but keep in mind row key is the only index to retrieve or update rows in the Bigtable. Using a write row key will impact the read and write performance. For example, pick up random keys such as UUID will perform best for writes, but poor for scan and sequential read operations. So the best practices of choosing the row key will be include multiple identifiers in your row key. For example, odd number, hash odd time as the row key, or using row key prefixes for multi-tenancy. For example, use your unique ID for each company as a row key prefix to store and track purchase histories on behalf of many companies. You should avoid non-reversed domain names, sequential numerical IDs, frequently updated identifiers, and hash values as the row key. As a general rule of thumb, keep your row keys reasonably short. Long row keys take up additional memory and storage, and it will increase the time to get a response. When you are in the exam, any questions on selecting the solution for storing time series data? The answer is Bigtable. The time series data schema design pattern is choosing between a tall and narrow table or a short and wide table. For time series, you should generally use tall and narrow tables, which are one event per row. As an optimization, you can use short and wide tables, but avoid unbounded numbers of events. For example, if you really need to retrieve an entire month of the events at once. Another issue you need to avoid is Bigtable hotspotting from any type of row key that contains a monotonically increasing value. There are two types to avoid hotspotting in time series data: field promotion and sorting. By default, prefer field promotion. Field promotion avoids hotspotting in almost all cases, and it tends to make it easier to design a row key that facilitates queries. In brief, when a row key for a time series includes a timestamp, all of your writes will target a single node, fill that node, and then move on to the next node in the cluster, that resulting in the hotspotting. So reverse timestamps only when necessary. Review this page for more details of the sample row key design patterns for time series data. I will continue the remaining sections of Cloud Bigtable in the next video. Continue the last-minute cheat sheet of Cloud Bigtable. The next is the key points on Bigtable instance management. You can configure one instance with up to 4 clusters or only one cluster without replication, one or more nodes per cluster. For cluster storage, usually SSD is most efficient and cost-effective, but it provides better write throughput than HDD. HDD is for lot latency sensitive or infrequently accessed. If you need to convert from existing HDD cluster to SSD or vice versa, you can export the data from existing instance, then import the data into the new instance. Or you can use the data flow or Hadoop MapReduce job to copy the data from one instance to another. Now let's take a look at the Bigtable's replication and changes. Bigtable can synchronize data between clusters. you can have up to 4 replicated clusters. When you add or remove nodes or clusters to the big table, there's no downtime on the changes. But when you change the disk type, for example from HDD to SSD we just mentioned, you need to export the data from the existing instance to the new instance. If the app profile uses a single cluster routing to direct all requests to one cluster, then you must use your own judgment to decide when to start forwarding over to a different cluster. If the app profile uses a multi-cluster routing, Cloud Bigtable handles the failovers automatically. There are 2 command line tools to interact with Bigtable, CPT tool and HBase shell. You can review the command reference for the details. After we talked about schema design, instance management, replication, and changes, it should be easy to understand Bigtable's performance. Pay attention to causes of slower performance and testing performance with Bigtable on this page. Based on the causes of slow performance, the following ways should improve the performance, such as choosing the right schema design patterns and role keys that I just mentioned in the previous section. Use replication, especially with a multi-cluster routing, to improve read throughput, adding clusters or nodes to improve write throughput. Use SSD to provide significantly better performance than HDD. You also need to memorize the guidelines of testing performance with big data before the exam, such as use a production instance. By the way, you can upgrade the development to a production instance at any time. Test with enough data. For example, if your production instance has one full load cluster and the tables in the instance contain a total of 1 TB of data, run your test using a table of at least 400 GB. Stay below the recommended storage utilization per node, such as SSD clusters with 2.5 TB per node, HDD clusters with 8 TB per node. Before your test, run a heavy pre-test for several minutes. Run your test for at least 10 minutes. You should also be familiar with how to get a performance overview with the Cloud Console, such as monitor CPU utilization, storage utilization, latency, and read-write replication operations. I didn't have any questions on Cloud Bigtable's IAM in my exam, but you can review this access control page, such as IAM management on project-wide instance or table level, admin user viewer read roles, and service versus user account, also the author scope. The last one you should study is the integration with the Cloud Bigtable, especially integrate with the BigQuery, Dataflow, Dataproc, and Cloud Functions. You can use BigQuery to query data stored in the Cloud Bigtable. You can use Dataflow to process data that is stored in Cloud Bigtable or to store the output of your Dataflow pipeline. You can run Hadoop jobs that read from and write to Cloud Bigtable with Dataproc. Next 2 videos, I will go through the cheat sheet of Cloud Firestore and the NoSQL Data Service Decision Tree. In today's last-minute cheat sheet for the PDE exam, let's go through Google Cloud's Enterprise Data Warehouse Service, BigQuery. I will focus on 4 areas in this cheat sheet: data warehouse for data storage and OLAP. BigQuery ML lets you to train and evaluate machine learning models directly in BigQuery. BigQuery BI engine seamlessly integrates with the familiar tools like Data Studio and will help accelerate data exploration and analysis for Looker, Sheets, and the other BI tools. BigQuery has the built-in GIS functionality to support geospatial analysis. You should get familiar with the key features before the exam. The key features are such as File Manager with auto-scaling from gigabytes to petabytes, serverless and no ops including ad hoc queries, BigQuery data transfer service, big data ecosystem integration, foundation for BI and AI, a programmatic interaction, data governance and security. If the exam question contains data warehouse, you should select BigQuery as the solution. This video will focus on last-minute cheat sheets, so I won't spend time explaining BigQuery's architecture, but you can review this article to understand what BigQuery hides under the hood. Now let's take a look at this sample data analytics architecture. This architecture is good enough to answer some pipeline questions in both PCA and PDE certification exams. The architecture has 3 patterns. The top one is real-time processing, the bottom one is batch processing, then provides data results from both processing to the BI tools for further exploring and visualization. The real-time processing uses PubSub to ingest the data, Dataflow to transform the data, and BigQuery to store and analyze the data. The batch processing uses cloud storage to store batch files, then Dataflow or Dataprep to transform the data as needed, then using the BigQuery to analyze the data. I will compare the difference between Dataflow and Dataprep on data transformation in the last-minute cheat sheet of Dataflow. Next one is BigQuery's structure. BigQuery has datasets and jobs that are contained with a specific project. Datasets are top-level containers that are used to organize and control access to your tables and views. Data sets can be regional or multi-regional. Jobs are long-running actions that BigQuery runs on your behalf to load data, export data, query data, or copy data. Let's take a look at the tables and views in the datasets. A table is a collection of columns with columnar storage. Tables can be external, for example, on the cloud storage. BigQuery has a collector to the cloud storage. For table schema, BigQuery provides a denormalization to increase query speed, but it requires more storage and increase the amount of data processed. Denormalized with nested and repeat columns can improve the efficiency of BigQuery with the relational source data. Schema auto-detection is available when you load data into BigQuery and when you query an external data source. Pay attention to unsupported schema modifications that you need to understand how to manually change table schemas. BigQuery provides partitioning and clustering for you to organize data through managed tables. Partitioning will filter storage before query execution begins to reduce costs. Reduce a full table scan to partitions specified. You can use any column with the date or timestamp or ingesting time or integer range for partitioning. Clustering is a storage optimization within columnar segments to improve filtering and record collocation. You can prioritize the clustering of up to 4 columns except listed columns. When should you use the clustering? You can use the clustering when your data is already partitioned on a date or timestamp or image range column, or you commonly use filters or aggregation against particular columns in your queries. Views are virtual tables defined by SQL query. I only point out the authorized view for the exam. The authorized view allows you to share data externally without sharing the underlying tables. Materialized view is a pre-PA at the time of recording this video. It is a pre-compute views that periodically catch results of a query for increased performance and efficiency. This is just a quick way to go through BigQuery structure. You should deep dive into the sections I highlight here from BigQuery documentation and get some hands-on experience to understand BigQuery structure before the PTE certification exam. I will go through more BigQuery last-minute cheat sheets in the next 2 videos. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time. Continue BigQuery's last-minute cheat sheet. I went through BigQuery's structure in the previous video. Now let's take a look at how to secure BigQuery's resources. Access control is through Cloud IAM. BigQuery namespace is global within a project. Datasets are multi-regional or regional. The basic rules for projects are viewer, editor, and owner. For dataset are reader, writer, and owner. BigQuery provides predefined rules for controlling access to resource on project, dataset, table or view level. IAM applies to datasets by using authorized views to restrict at a fine-grained level. Cloud IAM grants permissions to perform specific actions. BigQuery provides fine-grained access to sensitive columns using policy tags or type-based classification of data. The impact of a column-level security on views is independent of whether or not the view is in an authorized view. In both cases, column-level security is enforced transparently. Next one in BigQuery's security is encryption at rest. BigQuery automatically encrypts all data before it is written to disk. The default encryption at rest for BigQuery objects, data, and metadata is encrypted under AES. You can manage the key encryption keys with the Custom Manager Encryption Keys (CMEK) in Cloud KMS system. If you want to encrypt individual values within a BigQuery table, you can use the authenticated encryption with associated data encryption functions. To help meet compliance requirements, use Cloud Data Loss Prevention (Cloud DLP) to scan your BigQuery tables and to protect your sensitive data. Now let's move to interact with BigQuery. I won't spend time explaining interaction methods such as Web UI, BQ commands, REST API, and client libraries.
Also, if you have the knowledge of SQL, then there's no challenge to review the standard SQL and legacy SQL yourself before the exam. Highlight the topics that I think you should study more before the exam. The first one, querying multiple tables using a wildcard table, like you see in this example, and filter with the table suffix between in the query, like you see in this one. Second, previous queries are cached to avoid charges if run again. Third one, user-defined functions, UDF, is combined SQL code with JavaScript SQL functions, or combined SQL queries with program logic. It allows much more complex operations such as loopers, complex conditions, etc. The best practice for UDF is avoid using JavaScript user-defined functions. Use native UDFs instead. BigQuery can query data directly from cloud storage, Bigtable, SQL, and Drive. Support format are Avro, CSV, JSON, ORC, and Parquet. Pay attention to the limitation and the permissions for this kind of operations.
I will go through more BigQuery last-minute cheat sheet in the next video. Continue BigQuery's last-minute cheat sheet.
Next topic is data loading and exporting. You can ingest data to BigQuery with batch loading, streaming insert, reading from external sources, or using a third-party application or service. BigQuery Data Transfer Service supports the data sources such as cloud storage, YouTube channel, S3, Teradata, and Redshift. It can transfer the data directly into BigQuery. If data comes from Spark or Hadoop, consider using BigQuery connectors to ingest data. The data format supported in the BigQuery when you load denormalized last or repeat data are CSV, JSON, Avro, Parquet, data store backups. You can export your session and heat data from a Google Analytics 360 reporting view into BigQuery. Dataflow also can load data directly into BigQuery. You can export tables to Google Cloud Storage or copy to another dataset. Pay attention to export limitations, export formats, and compression types. The next topic is BigQuery's logging and monitoring. Cloud Auditor logs collect admin activity, system event, and data access information. Cloud monitoring will monitor performance, resource capacity, and usage. Metrics such as slot available and allocated available for the visualization. The last topic is the best practices of BigQuery data warehouse. I have mentioned several best tips in the previous topic, such as in BigQuery's structure, UDF, and loading data sections. I won't repeat them here again. The best practices really helped me to answer some certification exam questions, so I strongly suggest you spend some time reviewing them. I only highlighted the popular tips here. The first one is controlling costs. You will charge for data querying, so avoid use select all. Limit doesn't reduce the cost at all. Perform dry run to estimate the cost, or the query validator to estimate the number of bytes will read before you running those queries. The second one is performance optimization. I mentioned the partitioned table, cluster table in the previous video. use partition time field partitions, denormalize data, wildcard table with prefix, avoid tables sharded by date, avoid oversharding the tables, avoid repeated joins and subqueries, review the detail on avoiding SQL and patterns, such as self-joins and data skew, especially data skew for the exam. The third one is optimizing storage. Use the expiration settings to remove unneeded tables and partitions. Pay attention that you should keep your data in BigQuery for long-term storage instead of cloud storage. Next video, I will go through BigQuery's ML and GIS and how to use the cheat sheets to answer some PDE BigQuery sample questions. This is the final part of the last-minute cheat sheet of BigQuery. Please review the previous two videos of last-minute cheat sheets on BigQuery Data Warehouse before this one. I will go through two topics in today's video, BigQuery's ML and GIS. The PDE questions on those two topics will be on the high-level concepts. You won't be asked for providing any ML SQL such as create a model, training info, inspect weights, evaluation or prediction, or GIS functions. So I don't think you need to spend a lot of time on hands-on experience on BigQuery ML and GIS. The cheat sheets listed here should be good enough for the exam. Just understand the concepts on the MLs such as label, feature, model, and supported model types such as linear regression for forecasting, logistic regression for classification, matrix factorization for recommendation, etc. If the exam question contains geospatial processing, you should select BigQuery as the solution. I list two GIS functions and how to visualize BigQuery GIS data for your reference. BigQuery accounts for a larger proportion of the exam. Now let's use BigQuery's last-minute cheat sheets to take a look at some sample PDE BigQuery questions. Please read the question, pause the video and try to answer it yourself. Ready? I highlight the keywords of this question. The schema of these files will occasionally change. Schema auto-detection is available when you load data into BigQuery. The easy way to run, aggregate, and SQL queries is using the BigQuery for storage instead of cloud storage. So the answer is B. Want to try another one? Pause the video and read the question first. Ready? I highlighted the keywords of this question. Streaming inserts, unique ID for each row, and an event timestamp. The answer is mentioned in the BigQuery document manually removing duplicates from streaming data into BigQuery section. So the answer is D. How about this one? Pause the video and try to answer it yourself. Ready? I highlighted the keywords of this question. CSV file, fully imported successfully, not matching byte to byte to the source file. BigQuery expects CSV data to be UTF-8 encoded. In details of loading CSV data from BigQuery documentation, that generally your data will be loaded successfully, but it may not match byte for byte what you expect. To avoid this, specify the correct encoding by using the encoding flag. So the answer is C. Another one? This one should be easy to answer. Pause the video if you need time to answer it. Use Apache Spark to transfer data. The quick lift and shift solution in Google Cloud is Dataproc. Use ANSI SQL to run queries that store the data in BigQuery. So the answer is B. Another easy question. Pause the video if you need time to answer it. Ready? I mentioned this exam in querying multiple tables using a wildcard table, so the answer is D. This one does need time to analyze each answer. Pause the video when you are ready to check the answer. I highlight the columns in each update event. The answer A is wrong because the different term ID can publish the update event with the same publish time. The answer B is wrong because the messenger ID is created for each push attempt from each term ID, so messenger ID itself cannot use as unique key. The answer C is wrong because the inventory update depends on product checkout. So the correct answer is D, to add another column, order ID, for the product checkout. This is the last question on BigQuery. Ready for the answer? I mentioned this one in BigQuery's logging and monitoring. Cloud Audit logs collect data access, system event, and admin activity. So you want to discover what everyone is doing? The correct answer is A. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time. Hi, welcome back to the last-minute cheat sheet for the Google Cloud Professional Data Engineering Certification exam. Let's go through Google Cloud Dataflow's last-minute cheat sheet today. I don't like the way Dataflow's data documentation is organized. It is difficult to follow to pass the exam. I learned my lesson in my first try of the exam. So let's take a look at the Cloud Dataflow console first. Then I will go through the key topics in the way that I think will help you to pass the exam. When you log in Google Cloud Console, go to Dataflow. You will see two actions under Dataflow: Jobs, to create a data processing jobs, and Notebooks, to develop a pipeline by using Apache Beam Interactive Runner with the JupyterLab Notebooks. When you click Create Job from Template, under Dataflow Template, you will see the list of Google-provided templates, such as word count, streaming templates, templates for processing data continuously, batch templates, templates for processing data in bulk, and the utility templates. You can use your own custom template that you upload the code into the Google storage. Let's select a PubSub subscription to BigQuery to see what else you should fill to create the job. The template is a streaming pipeline that reads JSON format messages from a PubSub subscription and writes them to a BigQuery table. You will see the steps in the BigQuery diagram and the instruction on how to use this template. I will go through the components of the pipeline in the next video. You can follow the instruction to enter your parameter values in the Provide Parameter fields, then click Run Job button to finish creating the job. When you click Create Job from SQL, it will open a new BigQuery console with the data flow engine. After you enter the Dataflow SQL query into the query editor, you can click Create Cloud Dataflow Job to open a panel of job options. In there, you can click Show Optional Parameters to set any Dataflow pipeline options. You can also enter SQL query parameters, then create a job. You can also use the gcloud command to create and manage Dataflow jobs instead through the console. To launch Apache Beam Notebooks instance, you can click Notebooks, then click Add a new instance. Select Apache Beam and follow the screen or click Advanced Options to create a new Apache Beam Notebook instance. I want you to be familiar with Dataflow's console, so it will be easy to go through the cheat sheet. Dataflow's key features that you should remember for the PD exam are: Dataflow provides a unified batch and streaming processing. It is built on Apache Beam. It can change and transform data from one format into another. The Dataflow architecture diagram I put here will help you to understand the pipeline workflow. Dataflow is a black box that collects sources and sinks. Dataflow supports streaming, which is unbounded data, and batch, which is bounded data, then write into a variety of sinks. Apache Beam offers connectors for sources and sinks. You can see these connectors on the Apache Beam's document, built-in I/O connectors, or Google provided templates on these sources and sinks, such as file systems, for example, Hadoop file system, Google Storage, the messaging, for example, PubSub, Kafka, databases such as Cloud Spanner, Cloud Bigtable, BigQuery, etc. Dataflow offers a bunch of benefits under the hood like the other servers, including create the work VM to execute the job, optimizing the pipelines, scale the source up and down based on the workloads, monitoring and log collection. You need to distinguish between the API Apache Beam SDKs, which are used to create the pipeline, and the implementation execution framework, Cloud Dataflow, to execute the job. Each step of the pipeline does a filter, group, transform, compare, join, etc. Transformers can be done in parallel. I will go through the key points on Dataflow's jobs, pipelines, components, and transform operations in the next video. Continue Google Cloud Dataflow's last-minute cheat sheet. I went through how Dataflow works in the last video. Now let's take a look at the key points on how to build a Dataflow pipeline. Dataflow is built on Apache Beam. You use Apache Beam SDKs to define both batch and streaming data parallel processing pipelines. Let's take a look at an example of Google provided templates pipeline before we move to the key concepts of Apache Beam programming models. Let's select the text files on Cloud Storage to BigQuery template to understand the pipeline. The pipeline encapsulates your entire data processing task from start to finish. This includes reading input data, transforming that data, and writing output data. The first step is to read text files from Cloud Storage. Beam comes with a number of I/O library p-transformers to read and or write data to various external storage systems. If you click the Transform task, you will see the data processing operation or step, in this example PADO, which is called a p-transform. The distributed data set that your Beam pipeline operates on is called a p-collection. You can click each step, then you will see the linear pipeline, branch pipeline, and the merge pipeline in this example. I put the abstract diagrams here for you to remember the key terms in the pipeline: p-connection, p-transform, and I/O transforms that we just went through in the exam template. When you design a pipeline, you can choose the pipeline from linear pipeline, branching pipeline, or merging pipeline, or a composition pipeline with all three types like we saw in the exam. Also, the list of transform operations with one sentence summary for the exam. You can pause the video to go through the transform operations in Apache Beam's documentation. In all the core transformers, I want to highlight the PADO for the exam. When you apply a PADO transform, you will need to provide a user code in the form of a DoFun object. DoFun is a Beam's SDK class that defines a distributed processing function. You can use PADO to filtering a dataset, formatting or converting the type of each element in a dataset, extracting parts of each element in a dataset, and performing computations on each element in a dataset. I will go through how to aggregate elements in unbounded collections through windows, watermarks, and triggers in the next video. Continue Google Cloud Dataflow's last-minute cheat sheet. I went through how to build the Dataflow pipeline in the last video. Now let's take a look at how to aggregate elements in an unbounded collections through windows, watermarks, and triggers. With an unbounded data set, it is impossible to collect all of the elements, since new elements are constantly being added and may be infinities through the streaming data. If you are working with unbounded P collections, then you need to use windowing. By default, there's a single global window. Before you can use a grouping transform, such as group by key on an unbounded P collection, you need to define a non-global windowing function or non-default trigger. I put 3 non-global windowing functions diagrams here for you to easily memorize for the exam. The tumbling windows with the fixed time windows that each window might capture all elements with the timestamps that fall into a certain interval, for example, 30 seconds. Hoppling windows with the overlapped sliding time windows that each window might capture, for example, 60 seconds worth of data, but a new window starts every 30 seconds. The frequency with which slide windows begin is called the period. So in our example, it will have a window duration of 60 seconds and a period of 30 seconds. The last one is a session windows. It contains elements with a gap duration of another element. The gap duration is an interval between new data in a data stream. If data arrives after the gap duration, the data is assigned to a new window. For example, a session window can be used for the game session or user shopping session. However, windowing functions may not be able to handle the delay items. Here is the situation. In any data processing system, there is a certain amount of lag between the time a data event occurs and the time the actual data element gets processed at any stage in your pipeline. so Beam tracks a watermark. The watermark is a threshold that indicates when data flow expects all of the data in a window to have arrived. Beam's default windowing configuration tries to determine when all the data has arrived based on the type of the data source, and then advanced the watermark past the end of the window. However, this default configuration does not allow late data, so use triggers to modify and refine the windowing strategy for this situation. Beam provides the event time triggers, which operate on the event time, processing time triggers, which operate on the processing time, data-driven triggers, which operate by examining the data as it arrives in each window, and firing when that data meets a certain property. Currently, data-driven triggers only support firing after a certain number of data elements, and composite triggers, which combine multiple triggers in various ways. I also put 2 sample codes here so you can see how to combine windowing, watermark, and trigger to aggregate elements in unbounded connections. I will go through the remaining data flow's last-minute cheat sheet, the comparison between data flow and data proc to data processing service from Google Cloud, the comparison between data flow and data prep to data preparation service from Google Cloud in the next video. Continue Google Cloud data flow's last-minute cheat sheet. I went through how to aggregate elements in unbounded connections through windows, watermarks, and triggers in the last video. Now let's take a look at the key points of the remaining data flow's last-minute cheat sheet for the PDE exam. I covered creating jobs and pipelines in the last 2 videos. Now let's take a look at how to update and stop jobs. Based on the documentation, you cannot update batch pipelines, but you can update ongoing streaming job. You can launch the replace job with the update option and set job name option in the pipeline options to the same name as the job you want to update. If any transform names in your pipeline have changed, you must supply a transform mapping and pass to use the transform name mapping option. Pay attention to the caution. Give explicit names to every transform in your pipelines and the nodes. When you run with the transform name mapping, you may need to escape the quotations as appropriate for your shell. If the job compatibility check fails, you should stop the current job and create a new job instead. Google Cloud Data Flow provides the 2 options to stop a job, cancel and drain. Cancel will immediately stop job and abort all data ingestion and processing, so any buffered data will be lost. The drain command is currently only supported for streaming pipelines. It will attempt to finish processing any remaining buffered data, so if you saw any question in the exam that you need to update the streaming pipeline but you do not want to lose any data when making this update, then choose the drain option to stop your job, tells the data flow service to finish your job in its current state. The next topic for the exam is the access control. You only need to remember 4 IAM rules for the data flow admin, which is for pipeline access plus machine type storage bucket configuration access, data flow developer, which is for pipeline access, no machine type storage bucket access, data flow viewer, read-only access to all data flow related resources, data flow work specified for the service accounts to execute work units for the data flow pipeline. You will also have the question on how to handle the errors and exceptions from data flow pipeline. So take a time to review the details of common errors and pay attention to these two kinds of errors. One is input and output errors, and the other one is coding related exceptions. For example, exception from PADU, DoFn, and combine functions. I had a question on handling DoFn exceptions. If the failure is within the processing code of a DoFn, one way to handle this is to catch the exception, log an error, and then drop the input. The rest of elements in the pipeline will be processed successfully, so progress can be made as normal, but just logging the elements isn't ideal because it doesn't provide an easy way to see these malformed inputs and reprocess them later. A better way to solve this would be to have a data file where all of the failing inputs are written for later analysis and reprocessing. We can use the side output in the data flow to accomplish this goal. You need to check the latest Apache Beams SDKs on how to handle the exceptions before the exam. I will go through the comparison between Dataflow and Dataproc, two data processing servers from Google Cloud, the comparison between Dataflow and Dataprep, two data preparation services from Google Cloud, and the sample Dataflow PDE questions in the next video. Continue Google Cloud Dataflow's last-minute cheat sheet. We finished the Dataflow's exam topics in the last 4 videos. Now let's do a comparison of Dataflow and Dataproc. Both are data process servers from Google Cloud. Cloud Dataproc is recommended for existing Hadoop Spark applications or machine learning and data science ecosystem or large batch jobs with Primrose VMs. Cloud Dataproc doesn't support the streaming process like Dataflow does. Dataproc does not natively connect to PubSub, but PubSub can use a single endpoint with the Dataflow to process the messages. And Dataproc requires a DevOps approach, but Dataflow is a fully managed service. Now let's take a look at the difference between Dataflow and Dataprep on data preparation, transformation, or cleansing. Dataflow does not provide anomaly detection, Dataprep does. Dataprep can be used to handle schema changes by data analysts without any programming knowledge, but through the GUI. Dataflow requires programming knowledge on Apache Beams SDK. Dataflow also accounts for a larger proportion of the exam like BigQuery, and you will see the questions on PubSub, Dataflow, and BigQuery pipeline. Now let's use Dataflow's last-minute cheat sheet to take a look at some sample PDE Dataflow questions. Please read the question first, pause the video, and try to answer it yourself. Ready? I highlight the keywords of this question. Streaming pipeline for mobile game. Handle out of data delayed up to 15 minutes. And per player basis. We can't use the single global window on per player basis. The question didn't mention any on-prem Kafka messaging or specific messaging requirement, so the correct answer is A. Choose staging windowing with a minimum gap duration of 15 minutes and use PubSub as the message bus for ingestion. Wanted to try another one? Pause the video and read the question first. Ready? This question is very straight. User sessions time out after 30 minutes. So the correct answer is C.
Let's take a look at another easy question. Pause the video if you need time to answer it. Ready? This question is similar to the previous one on user's session timeout, so the correct answer is C. How about this one? Pause the video and try to answer it yourself. Ready for the answer? I highlight the keywords of this question. Write this to both BigQuery and Bigtable simultaneously. Minimum end-to-end latency to be completed as quickly as possible. You can use Apache Beam provided Bigtable and BigQuery I/O transforms to complete the pipeline quickly, so you don't need to use cloud storage as an intermediary. Loading the data from cloud storage to the BigQuery and Bigtable will increase the latency, so the correct answer is C.
Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time. Hi, welcome back to the last minute cheat sheet for the Google Cloud PDE certification exam. Let's go through Google Cloud Dataprog's last minute cheat sheet today. Dataprog's key features that you should remember for the PDE exam are: run the Hadoop Spark ecosystem on GCP Dataprog, used for large-scale batch processing and machine learning, manage the hardware and configuration, scale cluster up and down even when the jobs are running. When you lift and shift your on-prem Hadoop ecosystem into Google Cloud Dataprog, pay attention to best practice of migration such as separate storage and compute, simplified workloads, simplify the storage capacity if applicable, such as HDFS to the cloud storage, HBase to Bigtable, Hive to BigQuery. You can add the optional components as needed. You also need to pay attention to the performance optimization and the cost saving for the exam. You can review the Hadoop ecosystem cheat sheet from my blog. I summarize each component in the Hadoop ecosystem, their high-level functionality and purpose. Now let's take a look at what kind of configuration you can set up for Dataprog cluster. You can create a cluster through console, gcloud command with YAML file, deployment manager template, and Cloud SDK REST API. In the setup cluster, you can set up a region and zone, for example, global or regional endpoint, the cluster type such as a single node, which is a one master node and 0 work node, or standard, which is a one master node with many workers, or high availability, which is 3 masters with many workers. You can set up a Dataprog version. The default is latest. You can enable component gateway to secure access to web endpoints and select optional components. The configure nodes is optional. You can configure master nodes VM options such as machine type, primary disk type, and local SSDs. You can do the same thing on the worker nodes. Set up the minimum number of worker nodes, CPU, GPU, or VM options. You can also configure the secondary work nodes. Pay attention to the rules for preemptible. Preemptibles and to the Cloud Dataprog cluster only function as processing nodes. Cloud Dataprog cannot create preemptible only clusters. As a default, all preemptible workers are created with the smaller of 100 GB or the primary work boot disk size. The disk space is used for local cache of data and is not available through HDFS. The managed group automatically re-ends workers lost due to the reclamation as the capacity permits. The customized cluster is also optional. You can configure the cluster with the VPC or shared VPC. If you create a cloud Dataproc cluster with the internal IP address only, attempt to access the internet in an initialization action will fail unless you have configured routes to direct the traffic through a NAT or a VPN gateway. Without access to the internet, you can enable private Google access and place job dependencies in cloud storage. Cluster nodes can download the dependencies from cloud storage from the internet IPs. If you need a piece of data to be available to your cluster and also used as an API search parameter, then add it both as metadata and as a label to your cluster. The last optional configuration is the Managed Security. You can enable API access to all Google Cloud services in the same project. You can use either Google Managed Key or Customer Managed Key for encryption. You can enable Dataproc personal cluster authentication to allow interactive workloads on the cluster to securely run as your end user identity. You can also configure Kerberos secure mode to provide user authentication, isolation, and encryption with a Dataproc cluster. I will go through the key points on Dataproc's connectors, data storage, performance optimization, and cost saving in the next video. Continue Google Cloud Dataproc's last-minute cheat sheet. I went through Dataproc's clusters configuration in the last video. Now let's take a look at the connectors and the data storage. In the Dataproc cluster diagram, there are three types of nodes: master, primary workers, and secondary workers that we went through in the previous video. There are four types of data storages: local HDFS, a distributed file system that provides high throughput access to application data. Cloud storage is always a primary data store choice in GCP with HDFS compatibility. The cloud storage connector is an open source Java library that lets you to run Apache Hadoop or Apache Spark jobs directly on the data in the cloud storage. Cloud Bigtable is an excellent option for any Apache Spark or Hadoop user that requires Apache HBase. Cloud BigQuery provides data warehousing service or Apache Hive replacement, and you can use the BigQuery connector to enable programmatic read and write access to BigQuery. I also summarized the best practices on cluster performance optimization and cost saving for the PDE exam. So you should place Dataproc cluster in the same region as the storage bucket. Preemptible VMs for the secondary works, which will save the cost. Custom image, use custom image, which is the fastest time to reach an operational state. Persistent SSD boot disk, which will faster the boot time. SSD over HDD for better performance, but with a higher cost. Use SSD persistent disks for the master or workers. Attached GPU use, which will faster processing for some workloads, but with a higher cost. Pay attention to
the choice between HDFS versus the cloud storage. Use cloud storage to reduce the disk requirements and save the cost. Use local HDFS if the jobs require a lot of metadata operations, need to modify the HDFS data frequently, heavily use append operations on the HDFS files, the workloads with heavy I/O, or I/O workloads need a very sensitive to the latency. I will go through the key points on Dataproc jobs, templates, and accessing the cluster in the next video. Continue Google Cloud Dataproc's last-minute cheat sheet. I went through Dataproc's connectors and data storage in the last video. Now let's take a look at Dataproc's jobs and workflows. By the way, I did the video on how to run the Spark job in Dataproc and Cloud Composer, so you can learn from that video on how to submit jobs or how to run workflow templates from Cloud Composer. I will focus on key points for the PDE exam in this video. You can submit jobs or workflows through Console, G-Cloud Command, and REST API. Dataproc jobs will not automatically restart on failure by default. Optional settings on maximum number of retries per hour or the maximum number of total retries. You can start the workflow template from Cloud Composer, Cloud Functions, and Cloud Scheduler, but focus on Cloud Composer for the exam. You can access the clusters through Cluster Web Interface, Dataproc Component Gateway, and VPC Network. Pay attention to the red alerts. Reviews specify a source IP range of subnet firewall rules. Create an SSH tunnel to establish a secure connection to your cluster's master instance. SSH tunnel supports traffic proxying using the SOCKS protocol. Create a SSH tunnel for a secure connection between your web browser and Dataproc's master node. Cluster created with Dataproc image version 1.3.29 and later doesn't rely on SSH tunnels or modifying firewall rules to allow inbound traffic. External dependencies can either be bundled into a custom image or the Internet outbound request can be securely routed using NAT gateway. Now let's move to the key points of Dataproc's IAM. Pay attention to the red alert. Dataproc users are required to have a service account act as a permission to deploy Dataproc resources. You can also set permissions at the project level with the project owner, editor, and viewer rules. Cloud Dataproc IAM rules are Dataproc admin, editor, viewer, worker. Editor has full access to create, delete, edit clusters, jobs, and workflows. Viewer has view access only. Worker has assigned to service accounts with a read-write to GCS, write to the cloud login. Please review IAM rules and the Dataproc operation summary table. I didn't have any questions on Dataproc's logging and monitoring in the PDE exam, but I summarized them here for your reference. The job drive output is gathered automatically, so no need to connect to the cluster web interface for job status. Cloud logging is on Yarn container, cluster, and job logs. The default is set to info. It can be set to debug when a job is submitted from the command line. Cloud monitoring has HDFS, Yarn job metrics, and operational metrics.
Let's use the cheat sheets to answer some PDE DataProc sample questions in the next video. This is the final part of the last-minute cheat sheet of DataProc. Please review the previous 3 videos of last-minute cheat sheet on DataProc before this one. Now let's use DataProc's last-minute cheat sheet to take a look at some sample DataProc questions from the PDE exam. Please read the question, pause the video, and try to answer it yourself. Ready? I highlight the keyword of this question. Two phases delivery. Separate analytics and data processing with the BigQuery and data flow in the phase 2. So the correct answer is D. Want to try another one? Pause the video and read the question first. Ready? The answer is very straight based on DataProc's last-minute cheat sheet part 2, connectors and data storage. But I highlighted the keywords of this question on how to rule out the wrong answers. Reuse Hadoop jobs rules out the answer A. Be able to persist data beyond the life of a cluster rules out the answer B and E. By the way, you can review the difference between persistent disks and local SSD in GCP GCE storage options video. Minimize the management of the cluster rules out the answer C, so the correct answer is D. How about this one? Pause the video and try to answer it yourself. Ready? I highlight the keywords of this question. Bigtable is the solution for time series database. You can review the last-minute cheat sheet on Cloud Bigtable vs. FileStore Part 1, Cloud Bigtable Schema Design for more details on time series database. You can't write the message directly to Bigtable because of the requirement that the agents must not have permission to modify or read data written by other agents. So the correct answer is A. Another easy question. Pause the video if you need time to answer it. Ready? The correct answer is B. BigQuery uses ANSI SQL to run the queries. DataProc runs the Apache Spark transformation job. This question looks difficult and may seem focused on Airflow's operators, but if you pay attention to the keywords of this question, it will be easy to answer. Pause the video if you need time to answer it. Ready? You want to maximize query speed, so loading data into BigQuery will provide a better query performance than creating the external table in BigQuery. You can review it in BigQuery's last-minute cheat sheet. This is the last question on DataProc. Ready for the answer? The keywords of this question are minimize the storage cost of the migration. So the cloud storage is a primary data store for GCP with the HDFS compatibility. Using cloud storage to reduce the disk requirements and save the costs. This topic is mentioned in the DataProc last-minute cheat sheet part 2, connectors and data storage. So the correct answer is A. Hi, welcome back to the last-minute cheat sheet for the Google Cloud certifications. This is the last topic of the GCP PDE exam. Please subscribe to my channel, leave your comments or question on the last-minute cheat sheet series. Let's go through Google Cloud PubSub's last-minute cheat sheet today. The question of PubSub in both GCP PCA and PDE exams are pretty easy.
Any question in the third exams on messaging service, you should consult PubSub. You may have questions that you need to choose the solution between PubSub and Kafka in the PTE exam. PubSub is very similar to the Kafka, but I will compare the difference with the exam tips between these two in the next video. Before we go through PubSub's message flow diagram to understand how PubSub works, let's take an overview on PubSub. Google Cloud PubSub is a fully managed messaging service and ingestion for event-driven systems and streaming analytics. It offers durable message storage and real-time message delivery with a high availability and consistent performance at scale. PubSub provides global messaging routing to simplify multi-region systems. From the PubSub message flow diagram, you can see it decouples sends and receivers. A publisher first creates a topic in the PubSub service and sends messages to the topic. A message contains a payload and optional attributes that describe the payload content. Then the service ensures that published messages are retained on behalf of subscriptions. A published message is retained for a subscription until it is acknowledged by any subscriber consuming messages from that subscription. PubSub forwards messages from a topic to all of its subscriptions individually. A subscriber receives messages either by PubSub pushing them to the subscriber's choosing endpoint or by the subscriber pulling them from the message. The subscriber sends an acknowledgement to the PubSub service for each received message. The service removes acknowledged messages from the subscription's message queue. The communication between publisher and subscriber can be one-to-one, one-to-many, many-to-one, and many-to-many relationships. PubSub provides both push and pull delivery. PubSub simplifies event distribution by replacing synchronous point-to-point connections with a single, high-availability asynchronous bus. So the publisher never waits. A subscriber can get the message now or anytime within 7 days. PubSub guarantees at least once delivery. A subscriber asks each message for every subscription. A message is resent if a subscriber takes more than a deadline to respond. Messages are stored for up to 7 days. A subscriber can extend the deadline per message, but the latency out of order duplication will happen in PubSub. To solve these issues, Cloud PubSub and Cloud Dataflow can work together to provide exactly once ordered processing. PubSub handles exactly once delivery, and Dataflow handles deduplication, ordering, and the windowing. Separation of duties enable a scalable solution that surpasses bottlenecks in the computing messaging systems. You can review the last-minute cheat sheet of Cloud Dataflows to learn more details of data processing in Dataflow. Now let's take a look at the publisher and subscribers endpoints. You can see in the diagram the publisher can be any application such as end users, web or mobile applications hosted on the Google Cloud Computer Engine or on-premise network, or streaming IoT data from IoT devices, or the third-party on-prem legacy service, as long as the application can make HTTPS request to the pubsub.googleapis.com. The subscribe can be Dataflow or other processing pipeline services to the data warehouse or data replicas, or the services microservices on the Cloud Functions or GCE or GAE or GKE. Even the legacy and third-party service, as long as the pool subscribes can make HTTPS requests to pubsub.googleapis.com. Push subscribes must be webhook endpoints that can accept a POST request over HTTPS. The last one is the PubSub integration diagram. You can see PubSub can integrate with many components of Google Cloud. I will skip PubSub's monitoring and audit logs since there wasn't any question over these two topics in my PTE exam. I will go through the IAM, message encryption, and PubSub vs Kafka in the next video. Continue Google Cloud PubSub's last-minute cheat sheet. I explained how PubSub works in the last video. Now let's take a look at message encryption. I summarized the key points of message encryption for the exam. You can learn the details from Google's documentation. PubSub encrypts messages with the Google Manager keys by default, but you can also use the Custom Manager Encryption Keys (CMEK). It uses a service account to access Cloud KMS. Every message is encrypted at rest and in transit. Pay attention to the PubSub's access control note. PubSub is not associated with any specific IP address. This is relevant if you rely on IP-based firewall rules. The key points for IAM permission and rules are: Google Cloud PubSub allows for controlling access at a project, topic, or subscription level, so the IAM rules on the project level still are owner, viewer, and editor. But on the each resource level, for example, topic, subscription, or the snapshot are admin, viewer, editor, publisher, and subscriber. You can review the rules table for more detail. PubSub IAM API lets you set and get policies on individual topics and subscription in a project. Service accounts are recommended for almost all use cases. Now let's compare the difference between Kafka and PubSub. Kafka and PubSub are very similar to each other. PubSub is Kafka's alternate solution in GCP with no ops and serverless. I provide the comparison between Kafka and PubSub here for your reference. If you are unfamiliar with Kafka, then you should at least learn Apache Kafka's architecture and concepts from Apache Kafka's website. The first difference is message delivery. Kafka promises to deliver messages exactly once. PubSub guarantees at least once delivery, but PubSub can work with Dataflow for exactly once delivery. The second difference is the message retention period. Kafka can consume messages published longer than 7 days ago. PubSub's message retention ranges from 10 minutes to 7 days, but you can store the post-historical messages in a database such as Cloud BigTable or Cloud BigQuery Data Warehouse. The third difference is on log compaction or random access. Kafka's log compaction ensures that Kafka will always retain at least the last known value for each message key within the log of data for a single topic partition. There's no equivalent feature in PubSub, and also the compaction requires explicit reprocessing of messages or incremental aggregation of state. However, PubSub does provide replay and purge messages. You can consider use seek functionality to random message access. The seeking to a timestamp will discard the acknowledged messages manually after a retention period. The last one is on message ordering. Kafka provides keyed message ordering to promise the message ordering within a single partition of a topic. PubSub has an ordering key to guarantee the messages successfully published by a single publisher for the same ordering key in the same region. I also highlighted the exam tips for you to answer the questions on Kafka and PubSub in the exam. The number one is always consider PubSub first for your answer. The typical messaging in the data analysis pipeline is PubSub to Dataflow to BigQuery. As I mentioned in the Dataflow versus Dataproc video, Dataproc does not natively connect to the PubSub. Keep that in mind. If the question's requirement is to quickly lift and shift from on-prem to the Google Cloud or reuse Kafka's features such as Kafka mirroring, random offset access, then you should use Kafka or use the PubSub Kafka connector between the on-prem and the cloud. Or you can work the Dataflow with Kafka's I/O for data processing. Please make sure to check the PubSub's release notes on the latest GA features to migrate Kafka into PubSub before your exam. For example, PubSub's message filtering, message ordering, and dead letter topics. Now let's use the PubSub's last-minute cheat sheets to take a look at some sample PDE questions. Please read the question first, pause the video, and try to answer it yourself. Ready? PubSub's message retention period is 10 minutes to 7 days, so we can choose PubSub for this question. PubSub uses timestamp for its seek functionality, so the correct answer is A. How about this one? Pause the video and try to answer it yourself. Ready? This question requires you to do client-side encryption prior to sending your data to cloud storage. Two components need to be considered in this encryption at rest: cloud storage and Kafka load. So you need to supply your own encryption key as part of the API service course to these two components. The correct answer is D.
Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.
In this video, I will go through the last-minute cheat sheet on machine learning for Google Cloud Professional Data Engineer Certification exam. First, let's review the exam guide on what machine learning contents will be in the PDE exam. It will test 4 components in ML: leveraging pre-built ML models as a service, deploying a ML pipeline. By the way, I didn't have any questions on Kubeflow in my exam. Choosing the appropriate training and serving infrastructure. I did have the question on hardware accelerators. And measuring, monitoring, and troubleshooting machine learning models. I reviewed the tons of machine learning materials, including Google Cloud documentations, and CloudNext videos before the exams. Based on the exam guide and my exams experience, I feel this short learning materials list will save your learning time, and you should study them in the order that I provide here. The first one is Machine Learning Crash Course. This self-study course is designed for everybody who wants to learn machine learning in general, even for the person who has little or no machine learning background. It is provided by Google for free. It covers the key machine learning concepts that you need to pass the exam. I learned this course after I failed the first attempt of the PDE exam, and it did help me a lot to pass the exam in the second attempt, such as the questions on L1 versus L2 regularization, overfitting versus underfitting, how to handle IMSE and AUC. So you should take this course first before any other training materials. The second one is Smart Analytics, Machine Learning, and AI on GCP. You can take it in Coursera or Pluralsight. It focuses on Google solutions for machine learning such as AutoML, BigQuery ML, and pre-built ML APIs. This course is inside of the PDE certification journey with the 1 month free access at the time of recording this video. It includes hands-on laboratories to build machine learning models on Google Cloud Platform using QuickLabs. You can check my video how to pass the Google Cloud Professional Data Engineer certification in 14 days after first attempt to get more information on this free 1 month training offer. Next one is the Machine Learning APIs request from QuickLabs. This one is also part of a PDE certification journey free training offer. Now let's move to the Google solution article, Data Preprocessing for Machine Learning, Options and Recommendations. There are two parts of this solution. You only need to learn the first part for the PDE exam, because PDE will not test your deep knowledge on TensorFlow. It discusses best practice of pre-processing data in a machine learning pipeline on Google Cloud. Highlight the Figure 1, which will help you to understand the flow of data from raw data to prepared data to engineered features, then to machine learning. The second one you need to learn in this solution is the high-level architecture of a typical ML pipeline for training and serving on Google Cloud. Please study option 1 and option B for the exam. The article also made the summary table on the data processing options. Again, just focus on option A and B for the PDE exam. I found this Understanding Hyperparameters and its Optimization Techniques article is a good supplement to the crash course. It explained very well on the hyperparameter tuning versus model training. I do find it helpful to understand optimization in the test. You may want to read if you have time. The last one is the Google Cloud document on when to use TPUs. This document will help you to answer the questions on hardware accelerators. In general, you choose TPU for TensorFlow operations, but pay attention to the trick question based on the cloud TPU's limitation that I highlight here. Here is a summary of the options for ML models on GCP for your reference. You should pick up the option based on this order. First, try to leverage a pre-trained model in Cloud ML APIs, such as the Translation API, Vision API, Speech API, Natural Language API, Video Intelligence API, Data Loss Prevention API, and Dialogflow. The pre-trained model uses Google's model and Google's data. If a pre-trained model couldn't work for your case, then build a custom model with AutoML. AutoML is coordinates with the Google model and your data. For example, use AutoML Vision with your image data. If both ML options couldn't work for your case, then build a custom model with the Google API platform, such as load your ML models in Cloud TPUs, Spark ML in Cloud Dataproc, or using the BigQuery ML, or load your ML models in Cloud ML Engine. Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. Thank you.
Hi, welcome back to my channel. Let's go through the last minute cheat sheet of security in the GCP. You can use this cheat sheet for your GCP PCA and PDE exams. The first one is Identity and Access Management, Cloud IAM. GCP resources are organized hierarchically. In this sample resource hierarchy, organization node is the root node in the hierarchy. The projects are the children of the organization, and the other resources are the children of the projects. Each resource has exactly one parent. Folders level is optional for additional grouping and isolating between the projects. Before I summarize how to set up policies at each level, let's take a look at how IAM works first. With IAM, you manage access control by defining who has what access for which resource. IAM policy defines and enforces what rules are granted to which members, and this policy is attached to a resource. A policy is set on a resource. Each policy contains rules and rule members. Rule is a collection of permissions with the format service.resource.verb, for example, pubsub.topics.publish. There are three types of rules: basic rules, owner, editor, and viewer. The predefined rules are the rules that give a fine grained access control than the basic rules. You can also create custom rules to the needs of your organization when predefined rules don't meet your needs. In IAM, you grant access to members. Members can be a Google account for the individual users, service account for an application instead of individual end user, Google Group, a named connection of Google accounts and service accounts, Google Workspace domain, a virtual group of all the Google accounts, Cloud Identity domain, like a Google Workspace domain without access to Google Workspace applications, all authenticated users, a special identifier to represent authenticated user with any GCP account, and the all users, a special identifier to represent authenticated and unauthenticated users. Now, if you look back on the GCP hierarchy, you can set up policies at organization level, project level, and resources level. Resources inherit policies from their parent. Resource policies are a union of a parent and a resource. If a parent policy is less restrictive, it overrides a more restrictive resource policy. If you want to learn more of the IAM and the security of each individual Google Cloud service, you can review this service's last-minute cheat sheet video in my channel. You will have some questions on IAM for the cloud billing in the PCA exam. Now let's move to the cloud billing. There are two types of relationships govern the interactions between organizations: cloud billing accounts and the projects, ownership and payment lineage. Ownership refers to the IAM permission inheritance. Payment lineages define which cloud billing account pays for a given project. Here's a summary on the IAM for the Google Cloud billing. You can set up an IAM policy at the organization level, the cloud billing account level, and the project level. The billing rules defined in the cloud IAM. On the organization level, you can create a billing account creator, which create a new billing accounts. On the organization or billing account, you can have a billing account administrator, which manage but not create accounts. Billing account user, which link the projects to the billing accounts. Billing account viewer, which will view the billing account cost information and transactions. On the organization folder or project level, you can define the project billing manager, which is link the project to from a billing account, but no access to the project resources. I highlighted the IAM best practices for the exams, but you should review the details in Google Cloud documentation if you have time. The first one is the principle of the least privilege, that you should always apply the minimum access level required. When you use a service account, make sure rotate your service account keys. Be careful not to confuse the encryption keys with the service account keys. Don't check in the service account keys into the source code or leave them in the downloads directory. Use the logs from Cloud Audit Logs to regularly audit changes to your IAM policy. Export audit logs to the cloud storage for long-term retention. Restrict log access with the cloud logging rules. Use logs from Cloud Audit Logs to regularly audit access to the service account keys. Set organization-level IAM policies to grant access to all projects in your organization. Grant rules to a Google group instead of individual users when possible. Now let's move to the key management and data encryption. You can manage your keys with the Google Cloud KMS. Cloud KMS performs cryptographic operations and manages cryptographic keys. KMS is not a general-purpose secret store. You should use a secret manager for that capability. Cloud KMS resources include key rings, keys, and key variants. A Cloud KMS key is named object containing one or more key variants, along with the metadata for the key. A key exists on exactly one key ring tied to the specific location. The keys can be backed by software, hardware, HSM, or external system, EKM. A key's type determines whether the key is used for symmetric or asymmetric cryptographic operations. From IAM rules principle standpoint, you should avoid the basic project-wide rules. Using the Cloud KMS predefined rules for the least privilege and separation of duties. You need to manage the life cycle of your keys. The key management life cycle is divided into 4 phases: pre-operational, operational, post-operational, and destroyed.
In the pre-operational phase, you can do key import or key creation, both symmetric and asymmetric keys in the Cloud KMS. You can store keys which are created from software, HSM, or external protection levels, or perform the key rotation in the operational phase. Cloud KMS also supports key destruction and recovery in the post-operations phase. Next one is data encryption options. Google Cloud supports server-side encryption. The encryption occurs after Google Cloud receives your data. The data is encrypted at rest by default. Besides the standard Google Manager encryption keys, there are two extra kind of encryption keys, customer supplied encryption keys, CSEK, and customer managed encryption keys, CMEK. With the CSEK, you can create and manage your own encryption keys. Use your own AES-256 in the standard base 64 encryption keys with the GCP services. Keep the keys on the premise and use them to encrypt your cloud services. You provide the keys as the part of the API service calls, or the customer keys provided via the customer-side WOTO configuration file for the Google Cloud Storage. GCP uses the key in the memory and does not write it to the storage. Keep in mind CSEK is not currently supported by Cloud Storage Transfer Service, Dataproc, Dataflow at the time, and it is not available in all locations at the time of this video. With the CMEK, you can manage your encryption keys, which are generated for you by the Cloud KMS. Keep the keys in the cloud for directly use by the cloud services. You can create, rotate, automatically rotate, and destroy symmetric encryption keys. The other encryption is the client-side encryption. You encrypt the data on-premise or in your own application before it is sent to the GCP and decrypt it after it has been retrieved. If you use the customer-supplied encryption keys or the client-side encryption, you must securely manage your keys and ensure that they are not lost. If you lose your keys, you are no longer able to read your data, and you continue to be charged for storage of your objects until you delete them. You can encrypt disks with the CMEK and CSEK, but here are the two restrictions. You can encrypt only new persistent disks, images, and snapshots with your own key. You cannot encrypt existing resources with your own key. You also cannot use your own keys with local SSDs because the local SSDs do not persist beyond the life of a virtual machine. Local SSDs are already protected with an ephemeral encryption key that Google does not retain. You can review Google Cloud Network Connections Decision Tree and Google Cloud Load Balancers Decision Tree videos to get more information on the network in the GCP. If you knew the knowledge of the network in the other public cloud platforms, for example, in the AWS, then you should review this article, Google Cloud for AWS Professionals Networking, to save the time to learn the network in the GCP. In this video, I will only highlight the GCP shared VPC and VPC network peering. Let's take a look on the VPC network peering first. VPC network peering allows private IFC 1918 connectivity across two VPCs regardless of whether they belong to the same project or the same organization. For example, you can set up a cross-project or cross-organization VPC network peering. It is a decentralized or distributed approach to multi-project networking. It does not incur the network latency, security, and cost drawbacks that are present when using the external IP addresses or the VPNs. VPC network peering connection is not transitive. For example, if there are 3 VPCs, and then you need to create 3 connections peerings among them. For example, you need to create a peering between the VPC A and the VPC B, then the VPC B and the VPC C, and also the peering between the VPC A and the VPC C, because the connection is not transitive. Google Cloud also ensures that there is no overlapping subnet IP ranges allowed across the VPC networks. So you can imagine if there's more VPCs, and then the connections configurations will be very complicated. Is there a way to centralize the common resources management? Yes, then let's move to the shared VPC.
Shared VPC connects resources from multiple projects to a common VPC in an organization so they can communicate with each other securely and effectively using the internal IPs from that network. Shared VPC is used as a primary networking topology to enable centralized management of firewall rules and connectivity, useful for a service that must use resources from separate projects for independent accounting and billing. A project that participates in a shared VPC is either a host project or a service project. A VPC network peering allows peering with a shared VPC. So let's take a look at this example of VPC network peering with the shared VPC. You can see in this diagram, network SVPC is a shared VPC network in the host project P1. Service projects P3 and P4 are able to attach VM instances to the network SVPC. Network SVPC peers with the network A. So as a result, you can see the VM instances in the shared VPC service projects that are using the network SVPC, VM3, and VM4 have the private internal IP connectivity with any endpoints associated to the network A. VM instances associated with network A will have private internal IP connectivity with any endpoints associated to the network SVPC, regardless of whether those endpoints live in the host project or in a service project. It is possible to set up a VPC network peering between the two shared VPC networks. I summarized the difference between shared VPC and VPC network peering for you to make the decision for a particular situation. You can only set up a shared VPC in the same organization, but you can set up a cross-organization VPC peering. Shared VPC is a centralized approach to multi-project networking by configuring the security and network policy in a single designated VPC. On the other hand, VPC network peering is a decentralized approach that each VPC network can remain under the control of separate administrator groups and maintains its own global firewall and routing tables. This is all we have on the cheat sheet of the security in GCP. You can find more documents, guides, white papers, and blueprints of GCP security in the Google Cloud Security Best Practices Center. One of the white papers that you should review before your certification exam is the Google Cloud Security Foundations Guide. Please read the question first.
Pause the video and try to answer it yourself. Ready? When using Cloud IAM, a best practice is to follow the principle of least privilege. Owner allows full administrative access. This includes the ability to end members and set the authorization level of the team members. Based on the requirement, then the billing administrator role is good enough to set a budget and manage the billing accounts. View rule allows read-only access to view the bill account, cost information, and transactions. So the correct answer is B.
Thanks for watching, and as always, subscribe to my channel for more great cloud computing learning tips. See you next time.